Let's talk about one of the biggest mysteries in the entire universe. What actually happens if you fall into a black hole? It is a question that has stumped scientists for decades. But today, we're going to explore an idea that flips everything we thought we knew about black holes and maybe the universe itself completely on its head. So, what is inside a black hole? For the longest time, the answer our best theories gave us was, well, kind of a disaster. It's an answer that just can't be right, physically speaking. And this leads us to a massive paradox, a real crack in our understanding of reality. All right, so the whole problem really starts with how we think about gravity. About 100 years ago, Einstein completely changed the game with his new picture of how it all works. But when you take his ideas and apply them to the most extreme places in the cosmos, things get really, really weird. According to Einstein's general relativity, when a supermassive star finally kicks the bucket and runs out of fuel, its own gravity just takes over. It becomes so powerful that it collapses in on itself, forever. And all that stuff, the entire star, gets crushed down into a single point, a point with zero size and literally infinite density. We call that a singularity. Okay, but here's the catch. Whenever one of your physics theories spits out the number infinity, that's basically the universe's way of telling you you've made a wrong turn. Infinity is a concept in math, right? It's not a real physical thing you can hold or measure. It's a giant red flag telling us that our theory, as amazing as it is broken. It just can't handle what's going on at these insane scales. So to fix this, we have to think differently. We need to zoom in. I mean, way, way in. Smaller than anything we've ever imagined. We need a new theory that explains what the very fabric of space-time is made of. And this is where a fascinating idea called loop quantum gravity, or LQG, enters the picture. So loop quantum gravity suggests something truly radical. It says that space-time isn't some smooth, continuous sheet like a piece of paper. Nope, it's actually granular. It's woven together from these tiny, fundamental, indivisible units. It's kind of like a photo on your screen. If you zoom in close enough, you don't see a smooth image anymore, right? You see the individual pixels. LQG says space-time itself is made of pixels. And in LQG, these pixels of reality even have a shape. The smallest possible bit of space is what we call a quantum of space, and it's often pictured as a little tetrahedron, just like this. These are the fundamental atoms of space. You literally can't get any smaller than this. This is the bedrock of reality. Now here's the part that might just bake your noodle a little bit. These atoms of space, they don't exist in space. They are space. They link up with each other to weave the very geometry and dimensions that we live in. They literally create space by connecting to each other. And when you get trillions upon trillions of these quantum atoms all linked together, you get this incredibly complex structure called a spin network. And this isn't just some abstract drawing. According to loop quantum gravity, this network, this quantum weave of connections, this is the fabric of space-time. Okay, so let's bring this all back to our black hole problem. If space-time is a quantum weave, not a smooth sheet, then guess what? You can't crush it down to an infinitely small point anymore. It's impossible. The paradox of the singularity, it just goes away. And right here, you can see the difference. On the left, you've got the old idea, total collapse into that impossible point. But on the right, that's the quantum picture. The fabric of space can only be squished so far. Once it hits its absolute maximum density, this enormous outward pressure, a purely quantum force, fights back. It's like a cosmic trampoline. The collapse stops, dead in its tracks, and then violently rebounds in what we call a quantum bounce. And the result of this bounce is, well, it's just mind-blowing. The black hole, this place where nothing can escape, flips. It transforms into its exact opposite, a white hole, a region where matter can only go out. Everything that ever fell into that black hole over billions of years gets blasted out in a massive explosion. But what if that explosion is more than just the end of a black hole? Some physicists, like the brilliant Lee Smolin, think it could be something much, much bigger. What if it's the birth of a whole new universe? Smolin's theory, which he calls fecund universes, is this incredible idea that every single time a black hole bounces, it actually creates a brand new baby universe on the other side. And get this, just like in biological evolution, each new universe might be born with slightly different laws of physics, a tiny little mutation from its parent. This isn't just some new physics theory. It's a completely different way of seeing the cosmos. It takes us from thinking about the universe as a dead, mechanical thing to seeing it as something dynamic and, well, almost alive. For centuries, we've pictured the universe as this giant clockwork machine, just ticking away based on these fixed, eternal laws. But this new idea paints a picture of a universe that's more like a biological ecosystem. It reproduces through black holes, its fundamental laws can actually evolve over generations, and maybe, just maybe, only the universes whose laws are good at making more black holes get to have more kids. It's literally cosmic natural selection. And that leaves us with this one last huge thought to chew on. If this idea is even close to right, it means our universe isn't some special one-time thing. It's just one link in a cosmic family tree that stretches back for an eternity. And it really makes you wonder, if our universe can have children, what kind of universes will they grow up to be?